Assalamualaikum to my lecturer, Madam Norha binti Abdul Hadi. Today, I will be representing my group to tell you about thermodynamics. What is thermodynamics? Thermodynamics is the study of the effect of work, heat, and energy on a system. What is thermodynamic process? When the system undergoes change from one thermodynamic state to final state due to change in properties like pressure, temperature, and volume, the system is said to have undergone thermodynamics process. The key point is heat is a transfer of energy due to difference of energy. Work is a transfer of energy by mechanicals, but that means there is no heat involved. System is an object or set of objects we wish to consider. Anything else are referred as environment or surrounding. Thermal heat equilibrium. When two objects are defined to be in thermal equilibrium, if they are placed in thermal contact, when no energy flows from one to another and their temperature doesn't change. Internal energy. Internal energy is the total of the energy of the molecules of the system. The internal energy of the system would increase if work was done on the system or if work were done by the system and vice versa. Internal energy formula is equal to delta U is equal to 3 over 2 nR delta T. Laws of thermodynamics. There is 4 laws of thermodynamics. The first one is the zeroth law of thermodynamics, followed by the first law of thermodynamics, and then the second law of thermodynamics, and the third law of thermodynamics. The zeroth law of thermodynamics occurs when two thermodynamic systems are each in thermal equilibrium with a third one. Then they are in thermal equilibrium with each other. That means 3 of them are in thermal equilibrium. While the first law of thermodynamics states that energy can neither be created nor destroyed. It can only change form. Delta U is equal to Q minus W, whereas Q is equal to heat and W is equal to work done. Let's move to the question. Question 1 states that when 2000 joule of heat is added to the system and 1700 joule work is done on the system, what is the change of internal energy of the system?
So how do we solve the problems? So to solve the problems, we need to use the formula that is delta U is equal to Q minus W. Q is equal to 2000 and W is equal to negative 1700. E is equal to energy, Q equals to heat, while W is equal to works. Why is the work is negative 1700? This is because the work is done on the system. So when we use the equation E minus Q, E equal to minus Q minus W, so Q is equal to 2000 minus negative 1700. So the total energy is 3700 joule. So there are 4 thermal processes.
There is 4 thermal processes in this topic. The first one are isothermal. how do we know it is an isothermal process? In isothermal process, the temperature of the system doesn't change. The second one is adiabatic process. In adiabatic process, there is no heat flow into or out of the system. Next, we have isochoric. Isochoric system, highlight the word choric, which similar to water. That means the volume is constant. While isobaric formula, isobaric thermal process have the pressure to be constant. Let's move to question number 2. The question asks, during an isothermal process, 5 joule of heat is removed from an ideal gas. What is work done in the process? The answer is, in isothermal process, the work done is equal to the heat. That means our heat is negative 0.5. Why 0.5? Based on the question, it is stated that 5 joule of heat is removed from an ideal gas. So, they lost 5 joule heat. Because of isothermal process, W is equal to Q. That's why W that we get is negative 0.5 joule.
So for question 3, the question said that 2 moles of argon gas expand isothermally at 299 Kelvin from an initial volume equal to 0.05 meter to the power of 3. Assuming argon is an ideal gas, find A, the change in the internal energy of the gas, and B, the heat supplied to the gas. So the answer for question A is 0 joule. This is because isothermal reaction doesn't involve in change in heat. For question B, we know that the equation is P times V, that is P for pressure and V is for the volume, is equal to N times R times T. N is the mole, R is the Rydberg constant, while T is the temperature. So N is equal to 2, so when we move the equation from left hand side to the right side, we will get N times 8.135 times 298 times in bracket 0.05 divided by 0.025, and then which is equal to 2 times 8.315 times 298 times 2, and then the answer will get temperature is equal to 3435.644, or heat supplied is equal to 3035.644. So for question 4, we know that in an engine, an almost ideal gas is compressed adiabatically to half its volume. In doing so, 1850 joule of work is done on the gas. So the question is, how much heat flows into or out of the gas? With what is the change in internal energy of the gas? Drum rolls please. The answer is 0 joule, because adiabatic reaction doesn't allow heat move in or out of the system. So for question B is delta U is equal to negative W, and then W is negative 1850 in bracket of negative. So the answer is 1850 joule.
Now we will be moving to the second law of thermodynamics. The second law of thermodynamics says that the processes that involve the transfer or conversion of heat energy are irreversible. The second law also states that there is natural tendency of any isolated system to degenerate into more disordered state. When we talk about disordered state, we will talk about entropy. What is entropy? Entropy means The unavailability of a system thermal energy for conversion into mechanical work, often interpreted as the degree of disorder or randomness in the system. The second law of thermodynamics says that entropy always increases with time. Definition of the change in entropy as when an amount of heat Q is added is equal to delta S is equal to Q over T while the temperature is in Kelvin. Delta S is equal to negative delta SH plus delta SL, where delta SH is equal to QH over TH and delta SL is equal to QL over TL. Another statement of the second law of thermodynamics states that the total entropy of an isolated system never decreases. Now we're moving to question 5. The question states that an ice cube of mass 28 grams is taken from a storage compartment at 0 degrees Celsius and placed in a paper cup. After a few minutes, exactly half of the mass of the ice cube has melted, becoming water at 0 degrees Celsius. Find the changes in entropy of the ice or water. By using formula Q is equal to mc theta, we got that the theta is equal to, in bracket, 0.028 times 333 close bracket over 273, and we got that the theta is equal to 34.154 joule per kilogram. The Carnot cycle and efficiency of engine. An ideal reversible closed thermodynamic cycle in which the working substances goes through the 4 successive operations of isothermal expansion to a desired point, adiabatic expansion to a desired point, isothermal compression, and adiabatic compression back to its initial state. 4 processes of Carnot cycle are isothermal heat addition, which is happen in boiler, isentropic expansion happens in a turbine, isothermal heat rejection happens in a condenser, and isentropic compression happens in a compressor. In Carnot cycle, the most efficient heat engine cycle is Carnot cycle, consisting of 2 isothermal processes and 2 adiabatic processes. In order to approach the Carnot efficiency, the processes involved in the heat engine cycle must be reversible and involve no change in entropy. We got that conservation of energy is equal to QH is equal to W plus QL, where QH, W and QL are always positive. The change in internal energy of the system is delta U is equal to 0 because it returns to the starting state. Now we're moving to how steam engines work. In this picture, we can see that the high pressure steam intake valve open during expansion, then the exhaust valve closed during expansion, and then the piston moving and high steam from boiler is produced while lower pressure steam exhaust in condenser. This is the picture of internal combustion engine, which is piston. We know that pistons spin and spin and spin to produce heat. The heat engine. The efficiency of the heat engine is the ratio of the work done, W, to the heat input at the high temperature. We get the formula is E is equal to W over QH, where W is equal to work and QH is equal to heat input. Using conservation of energy to eliminate W, we find that E is equal to W over QH, which is equal to QH minus QL over QH. I repeat, E is equal to W over QH, which is equal to QH minus QL over QH. In other words, it's equal to 1 minus QL over QH, where QL is equal to heat discharge. The Carnot engine was created to examine the efficiency of a heat engine. It is idealized as it is no function. Each leg of its cycle is reversible. 1. The Carnot cycle consists of 2 isothermal expansion, which is T is equal to 0, while 2 adiabatic expansion, which is Q is equal to 0. Thank you, Madam Noor, for listening to our presentation.
Thank you, madam.